Hello students, so welcome again another lecture of engineering graphics. Today I am taking one problem on parabola. If you remember earlier we discussed about different methods for construction of conic section. There will be one method that is known as general method. Sometimes people also call that Directrix and eccentricity method. This method will be based on the definition of eccentricity, according to which for parabola eccentricity will be 1. So, I am taking a case of parabola when the problem will be like this, that there will be a point which is at a distance 50 millimeter from one of the fixed straight line, and it moves in such a way so that the distance from the fixed point and the fixed line remains same. So, as we know that that eccentricity will be 1, so that curve will be parabola. So, in this particular problem, what will be given to us, that is the distance of the focus from the directrix. So, how we will going to start? Initially, I have drawn a line, vertical line, that will be representing my directrix, that is AB line, and if I draw a line CD perpendicular to AB, then in future that is going to be the axis of the parabola. So, I have drawn AB and CD, and after that this distance CF will be given to me. This CF will be the distance of the focus from the directrix, that is given will be 50 mm. So, with the help of this distance I have marked this CF 50 mm. As you know that for parabola the eccentricity will be 1. So, that is 1:1. So, what we will do? We will divide this line CF into two parts. So, now the midpoint of this CF will be our vertex. So, that is the first point on the parabola. So, if you want to justify as the distance VF upon VC, that will be 1, it means this point will be one of the point on the parabola. Now, what I am going to do? I am going to maintain this distance and find out the points on the curve. So, next what I am going to do, on this point V, I am going to draw a perpendicular line that will be perpendicular on the line CD. After drawing this perpendicular, taking the V as center and this VF equals to radius, I am going to shift this point from here to here, and I will name this point as alphabet capital E. The condition will be what I have taken, that this VE equals to VF. Now, after that what I am going to do, that I am going to join this E point with the point C by a straight line, and I will move it further like this. Now, look at this right angle triangle, that is triangle CVE. Triangle CVE. In this triangle, this VE upon VC, as VE equals to VF, so that is VF upon VC, and that will be equals to 1. Now, after that what I am going to do, in between these 2 points I will mark randomly 2 points, may be equidistant apart, and then name them 1, 2. Further away from F I will mark another point 3, another point maybe 4, at any distance whichever you like. There is no botheration about the distance. Now, on this line 1, I am going to draw a line perpendicular to the baseline up to the point, up to this line, inclined line, and I will name this point as maybe 1 dash, and the same way this line will go downside also from 1. Now, look at this figure. Now, there are 2 triangles are available. One triangle will be CVE and the second will be C11 dash, as both are similar triangles, and you know that the property of a similar triangle will be the ratio of the sides will be same. So if for this first triangle this VE upon VC is 1, it means for the second triangle this 1 1 dash upon C1 is also 1. So in this triangle C1 1 dash, with the same logic, this 1 1 dash upon C1 will be equals to 1. So what I am going to do, I am going to check a point which will be at a distance 1 1 dash from the focus and C1 from the directrix, that is one of the point on the parabola. Now look at this line 1 1 dash. As this line is parallel to AB, it means the distance of all the points on this line from the C will be C1. So already I am getting this C1. So what I have to do, I have to take this 1 1 dash distance from here and take focus as center and cut this line. What I have done? I have taken this 1 1 dash radius, and with this radius from the F, I have cut this point. That may be our next point on the parabola. Maybe this point will be P1. Now look at this. The distance of P1 from AB will be C1, that is this figure, and the distance of P1 from F will be 1 1 dash, that is this value. So it means that is ratio will be again 1. So that is one of the point on the curve. The same way, at the same distance in the bottom side also we can get another point that can be P1. So these are the next 2 points on our parabola. Next time the same method I will apply, and on this point 2 I am going to draw a line perpendicular to the axis, and I will move it downside also. As you know that parabola will be symmetrical in both the sides of the axis. Now again we got another triangle. This time the triangle will be C2 2 dash. This point will be 2 dash. Now again 2 2 dash upon C2 will be 2 by 3. So as you know that the distance of all the points on this line 2 2 dash from AB will be C2. So it means our point must lie on this line, and I will pick a distance 2 2 dash, and from focus as center I will cut it. So maybe that is the next point P2. Now the distance of P2 from AB will be C2, and from focus will be 2 2 dash. So that is also one of the point on the parabola. Same way I can shift it downside, so I can get another P2 in the lower side also. Next time I am going to use this focus point, and this time I will draw a perpendicular on this focus. Suppose it will cut at some point F dash. Now my triangle will be CF F dash. Again with the same logic, for this triangle CF F dash, this F dash upon CF will be equals to 1. So this time there is no need to cut arc. This will be also our point on the curve, as the distance of this point from the focus will be FF dash, and the distance of this point from the directrix will be CF. Same method, I can mark a point downside, the mirror image of F dash point. The same method I will apply at these points 3 and 4. That is the same method. So I can get 2 more points. From 3 and from 4 upside there. So that may be 3 dash and 4 dash. Again the logic will be same. Take focus as center, radius equals to 3 3 dash. So this 3 3 dash will be the radius, center will be focus. From focus cut this line. Same way upside and downside. Then next time this 4 4 dash, and again the center will be focus. So now look at this figure, already we got multiple points. Now I can join all these points with free hand. So this is the required parabola by this method. I hope you understand the logic. The logic will be the distance of the moving point from the focus and the distance of the same point from the directrix remains same. So that curve will be a parabola. So this is parabola by general method. Or you can also call that Directrix and eccentricity method. In this particular problem, this distance will be given to us, the distance of the focus from the directrix. So with the same method, now you can also draw ellipse as well as hyperbola. So hope you understand the problem. Draw it in your notebook. Thank you very much.